On the other hand, many carnivores will talk about the Randle Cycle, but this is very outdated and came before we knew about things like Glucagon and GLUT4 transporters.
The Randle Cycle is not something that actually emerged just in the 60s without any research. It's quite clear that what it is. And we knew about insulin and we knew about, about glucagon and GLUT4. We knew about the GLUT receptors. We may have not understood very clearly how they all worked, but, that doesn't mean that we didn't understand that there was this effect. Just because you don't understand which GLUT receptor insulin is playing on, it doesn't mean you don't understand, because we've known for more than 100 years about insulin and glucagon, to remember out. So the Randle Cycle is not something that actually emerged. So we've known about glucagon since 1922, and the Randle Cycle was actually described in 1963 with a published research. So Randle knew about glucagon, knew about insulin, knew about all these sort of things. So I don't know where he's coming from claiming that the Randle Cycle is an outdated concept before we knew about glucagon, when we knew about glucagon 20 years earlier, and Randle knew about glucagon and insulin, and and also the GLUT receptors and all that. They knew about them as well, because it's described in the work. All the GLUT receptors and the CD36 receptor. I've got no idea what he's talking about personally, because we knew about these things. Randle, without knowing about these things, could not describe glycolysis and glycolysis and and beta oxidation. You have to have knowledge of all these receptors to be able to do that, and he did, because it's in all the diagrams that that he created. So I don't get it what he's saying, So yeah, and to claim that he didn't know about glucagon is ridiculous, because it was known 20 years earlier, and the receptors have been known. They may have not been fully understood to the level which we understand them now, but even now there are some gaps in our knowledge. But that doesn't mean that the Randle Cycle isn't real, doesn't happen. And we know quite clearly it does, because we see the construct of insulin resistance happening, where things stay in the bloodstream and don't actually get uptaken by cells because there's this blockade effect. So it definitely happens, and it's been tested, so we know it does happen, and it's been done in vivo and in vitro and in vivo type studies to be validated in terms of the cell behavior to substrates of excess energy coming in from two different sources. So we know it works. And glucagon was well known before, so I've got no idea what he's talking about. Look, people make all sorts of claims about things. They may have heard it somewhere and then repeat. This is the problem with repetition. When you hear something from someone and then you repeat it, the danger there is you'll repeat nonsense. And that's why a lot of the paleo stuff's coming back, and a lot of the other stuff keeps on regurgitating and coming back and forth all the time. Again, it's the same sort of issue. Too much nonsense that gets repeated.
The idea here is that eating carbs and fat together is supposedly very bad, even though there's really no time where you would be eating carbs alone anyway, not in nature, not in a natural whole food. The reality is that when you eat, the body shunts glucose into the muscles instead of burning as much glucose. It's just a simple misunderstanding brought about by outdated information from the early 60s.
No, that's not the case. The Randle Cycle is an increase of both in excess. You can actually have mixed diet, like many populations, and if you're under eating what your energy requirements are, or you're exercising heavily and you don't get excess, then you're not going to get the engagement of the Randle Cycle, or a very low gradient of it. It's the excess. It'll happen more to a couch potato than it'll happen to an athlete. until they become a couch potato and stop being a high-end athlete. So there is, and and just because you're putting in the muscle glycogen, whoopee. We store some fat and some glycogen in the muscle to be available close by. We also have around our organs, we don't need excessive amounts because it's a problem, but you need some level of visceral fat. That visceral fat provides immediate energy, rapid energy you can actually access very quickly because it's close to the actual organ to take it in. So, and it's the same thing with intracellular inside the actual, the both the cells and also the tissue itself. There are pockets in muscle tissue that'll have fat, that'll have glycogen to be available. That's normal stuff. It has nothing to do with the Randle cycle. The Randle cycle is mixed macros in excess, not single macros. That's why the vegans can actually waste away. And somebody on a strict low carb diet with a low insulin can do the same thing. There's a glucagon to insulin ratio that explains that. And that relates to the Randle cycle. When the insulin is high and the glucagon is lower, then basically that is hormonal signaling that relates to excess of both energies. Think system. Don't think just, these things. They're not all independent. They're interacting with what the cell's doing, and they're signaling, saying, this is changing. There's too much. If there's less, like when you're fasting, insulin to glucagon goes 0.8 to 1. Less insulin, more glucagon for gluconeogenesis. Plus, you need less because you want to increase the amount that you're pushing out in terms of glucose and free fatty acids. Because you're not eating energy, okay? Mass, you're not eating fat. So what you have to push glucagon slightly higher, the ratio to insulin, in order to basically, because even some insulin has an effect on hormone-sensitive lipase. How high hormone-sensitive lipase signaling has to do is where insulin is. Slightly higher, it will have a more suppressive effect on hormone-sensitive lipase. Hormone-sensitive lipase, and also have a suppressive effect on cortisol. And cortisol basically tells the body, we need more to generate more energy. So that's when it's signaling. It's not stress. That's not stress. That's telling the body to upregulate gluconeogenesis. It's a signaling thing, and it goes up and then comes down to baseline. But when you think in a reductionist crackpot way, you can't understand this interaction. This goes up, that goes down, that adjusts depending on what's coming in or what isn't in the system. These are signaling adjustments telling the body what situation is in terms of energy and substrates flowing through the body, and what we need to release and what we don't need to release. The body's not going to flood the body with certain things. And if you give it too much, then it's going to basically just take hormonal and receptor behavior from the signaling to shut down certain things and go, we're not taking this. The body is very smart, and it's got these regulatory systems and feedbacks that are interacting. That's why all the hormones are talking with the body continuously and adjusting slightly. The problem is crackpots can't think in that way as a system. They always think in a reduction of, this is doing, must be a disaster. No, you idiot. It's doing that because that other stuff is doing this other stuff. That's why. But you're a low IQ person and can't get your head around it to think in systems and how the body's responding to what's happening to it.
Eating fat also doesn't raise your triglycerides for long periods anyway. What does that is excessive carb consumption. So if this were true, then you would constantly see this effect on a high carb diet. But it's really just a product of a bygone era when we knew a lot less about the human body.
Now that's just nonsense as well. That's nonsense. When you're actually in a low carb state, you get what is called the peripheral resistance. That means the receptor site, GLUT4, doesn't take stuff in. And insulin is much lower as a consequence of that. As I said, If you put more of the other food in, insulin will go up. The insulin to glucagon will change. If you don't, it'll go further down. When it goes further down, what happens? You're not going to be pushing more glucose out than what you need. You do slightly more exercise, so you need glycogen. Well, you'll actually increase it slightly. These are dynamically adjusting all the time. That's just reductionist thinking. Oh, this is going to do that. Absolutely not. Even if it's circulating due to you've exercised and you need more for your muscles, it's not going to go into be utilized by the cell for energy production, for ATP. It's still going to use the free fatty acids. It will primarily, only slight excess that the body hasn't used for glycogen or anything else, that can go through GLUT1. And that does not require at all insulin. Okay? So there's a difference in that. The body can take out excess as well from the periphery, even though it has supposedly this construct of peripheral resistance. The body's a very smart thing, dynamically adjusting. It's like it does a beautiful dance. Unfortunately, most people struggle to, a lot of people out there, unfortunately. Also, isn't the Randle cycle only activated when the energy overplus? Pretty much. In general terms, yes. If you're under eating and you've got less, no, it's not going to happen because there's no excess in any of the cells. But if there's excess in the system, and also Randle cycle doesn't activate in every single cell at the same time or at the same degree. Depends on how much that cell sucked in. You can have cells closer to where the source of energy is coming in or being delivered, closer to those trucks that are moving the stuff around. And obviously they're going to take more in of certain things, and others that are further away in the periphery are going to take less and take less later and are going to have a different rate of Randle cycle activation. But talked about it, but he hasn't gone into detail because he doesn't want to complicate things or confuse people too much. But that's what's happening. There is variability there as well. But it is, in the general terms, if we're talking about general, sort of like an academic way of explaining it, yes, it is a surplus that you will get this sort of situation happening where the cells start going, nah, 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 and it does have that effect. And it's a gradient. That's what we call a gradient. If you've got severe, like very high insulin to glucagon, then you'll have a lockout, complete lockout, which is what happened on people on, very poor, sad diets, that you have this complete lockout. I've also talked about it on Pim's channel recently about how deuterium can actually increase the Randle cycle activation even at lower intakes of food because of mitochondrial damage.
Any way you slice it, carbs cause a lot of damage at the cellular level. The worst diet for producing mitochondrial damage would actually be a high-carb, high-protein diet, which is what most bodybuilders and other fitness experts promote.
Fat will have a slightly elevating effect on insulin to glucagon. So insulin will go up to 1.3, and if you put a bit more protein, up to 1.4 potentially. Less protein, 1.3, 1.4, to insulin to glucagon, the amount of signaling. That even bump from, 0.8 to 1.5 now, that is going to affect hormone-sensitive lipase. One, it's going to lower down the gluconeogenic effect as well, because more things are coming in, so the body's going, we're going to use other substrates. We don't need to use as many aminos, so let's clamp on that, and we'll use the other pathways. And, we don't need as much fat to come out as free fatty acids. So that little bump is going to push down slightly hormone-sensitive lipase, so less comes out of the adipose tissue, out of the fat cells. because we don't need as much. We don't want to overload the system. It's trying to regulate all these and work out demands and say, how much do the cells need in terms of glucose and in terms of fat, for glycogen, for the peripheral tissue, how much of this sort of stuff. And it's trying to manage all these energy, and these hormones are adjusting and signaling and telling the body, we need this amount, we need to lower that a bit, we need to increase this a bit, we need to make this adjustment, more of this guy's eating even more fat. Lower hormone-sensitive lipase even more, push insulin to glucagon slightly higher, the signaling, the ratio. So all these things are adjustments that are actually happening dynamically in the body, responding to all these changes that are happening, these dynamic changes. And that's what hormones are doing. You have to get your head to think as a system. If I put these different inputs, it's going to respond different. If I rev up my engine, it's going to push more fuel into that engine. If I don't rev it as much, it's not. That's a simplistic model of a system, but all systems behave in a very similar way. They will respond to the inputs, and respond in the way there is other components that require certain things. And if they don't get them, you'll hear some funny noises coming out of the engine. And it's the same thing with the body. And it's usually things like then oxidative stress and or inflammation and all these things. That's the noise our bodies make. So you've got to get your head beyond that reductions. And the problem is a lot of these people have very poor understanding of how systems work or our physiology works, and they can't escape this sort of reductionist thinking. And so when they see certain things, they go, oh, that must mean that, or that must mean this. Just nonsense, A higher of this, when all the other stuff are doing other things, can mean one thing. A higher of this, same signaling molecule when other things are doing other things, means something completely different, because it's a different relationship and it's affecting different pathways, different hormones, different receptors, different things in the body. These variabilities. Where is mTOR being expressed? mTOR is a growth factor, yes, thank you very much. But if it's being expressed in the bones and the muscles, that's a good thing, because you're growing stronger and bigger bones and healthier bones. If it's expressed in the adipose tissue, well, then it's a problem. It's pushing growth pathways that are unhealthy growth pathways. So there is a difference between one and the other. And this is a problem that people are constantly getting confused. And, it's endemic out there, or the amount of misunderstanding of how the physiology works,